Okay, guys. I'm gonna go over this review that we did the other day. It's not that difficult. It's just pretty much everything that we covered on that day, right? So let's go over this really quick. So here, the first question is asking you write a mixed number as an improper fraction, right? So first, we need to understand what is a mixed number, right? And here they give us a definition. Mixed number is a whole number and a proper fraction together. But before we go into mixed number, let's identify what's the difference between proper fraction and improper fraction. I apologize for that. The proper fraction is a fraction that is less than one, basically. So as they give you an example here, you have 1/2, 3/4, 5/7. As you can see, that's less than one, right? Also, it's very easy to tell if it's a proper fraction if the numerator is less than the denominator. You see that I highlight here in yellow that the numerator is less than the denominator, right? So you have 1/2, right? The numerator is 1, the denominator is 2. So 1/2 is less than 1, that's 0.5, 3/4 is 0.75, and so on and so on and so on, right? So once you know that numerator is less than the denominator, then you know it's a proper fraction. So improper fraction is a number greater than 1. You see here, like you have 4/3, you know that that's greater than 1. 7/3, that's greater than 1. 9/4, that's greater than 1, right? So how do you know it's an improper fraction? So the numerator is greater than the denominator. And again, the number should be greater than 1. What is a mixed number? Now we can talk about mixed number. Again, mixed number is a whole number. So here we can see the whole number, the 7 here, right? It's a whole number and a proper fraction. So we just discussed what is a proper fraction. Proper fraction means when the numerator is less than the denominator, right? And the number for the mixed number should be greater than 1, right? Of course, because you have a whole number, right? That is 7, and 2/7 is the proper fraction, right? But anyway, this is some decimal, right? And this is 7, so that's gonna be 7 and change, right? So they want you to write this mixed number, this right here, as an improper fraction, right? So you know that you're gonna get a number bigger than 1 anyway, right? So how you do this? Basically, these two you multiply, so that's gonna be 7 times 7 plus 2. So that's gonna be 49 plus 2, which is gonna be 51. That's it, right? So that's gonna be your numerator, and your denominator is gonna remain the same. So that's gonna be 51/7, which is option B, right? Again, mixed number, you multiply 7 times 7, right? And you add 2. 7 times 7, and you add 2. These two right here, right? And the denominator, like this fraction, this denominator will remain fixed. So as you can see, it didn't change at all. The only thing we're kind of solving, or we're trying to compute right now, is the numerator. So the numerator, again, is 7 times 7 plus 2. That's 51/7. If this is too easy for you, skip the video, go to the next question, and don't waste the time with the things that you already know. I'm just doing this just in case you have no idea what I'm doing, okay? Next question, number 2. Now they're asking you, write the improper fraction. We know what's an improper fraction. Improper fraction is a number greater than 1, right? So obviously that's greater than 1 as a mixed number, right? Or as a whole number. Okay, so this is what we need to write. Let me put that in blue or green, whatever. So we need to write this as a mixed number. So this is the reverse, basically, right? There's many ways to do it. The way I like to do it is, you know that the denominator is going to remain fixed, right? When we make it to improper fraction to mixed number, or from mixed number to improper fraction, the denominator stay fixed. Now, the way I like to think about it is 3 goes, like the main thing is how close you can get to 44, right? And the number that is close to 44, not passing 44, or not like that far from 44, you want to get as close as possible to 44, right? So basically you need to multiply this by 14, right? Because 14 times 3 is 42, right? So that's as close as you can get to 44. And then since these two you multiply, and then you remember, in reality we're just computing the numerator, right? So if you think about it, you do 14 times 3 plus 2, right? Because you need to get into 44, right? So we don't know this number technically, but we know that we need to multiply that whole number times that denominator. So that's going to be 14 times 3, and that's going to be 42, right? But I need to add this guy, right? So that guy should be 2, right? Because that's what we're looking for. So that means that this number should be 14 2/3, right? Now, if this doesn't make sense to you, you can do what your classmate, I think one of you said in class, I can divide these together, right? So you can do this, right? And you can say, well, I need to compute this. Let me see how can I solve this? So you do 1 times 3 is 3. If you subtract 3 from 4, you get 1. You bring down the 4, right? And then you multiply 4 times 3, that's 12, right? And you have a remainder of 2, right? So basically, this is your whole part. Your remainder goes in your numerator, and this number goes in the denominator, right? So that's how you can solve this. Not big deal. You can do it the way I did it, or you can do the long division, right? Again, if you want to see how I did it, again, I know that I need to keep my denominator fixed, and I want to get as close as possible to 44, not passing 44, but as close as possible. So the only number that is close to 44, not passing 44, is 12, because if I do 13, right? I'm sorry, I was saying that it was 14, right? If you do 15, that's going to be 45. So you are already passing this numerator, right? You don't want to do that. You want to be as close as possible. So the only number that is close as possible to 44 is 14, because 14 times 3, like I explained to you before, you need to get into 44, right? So 14 times 3 is 42, and you add 2 and you get the 44, right? So that's going to be 14 2/3. But if you don't want to go into thinking too much, you just divide those numbers and you get your answer, right? Okay, so that's how you do that one. Okay, so here they say perform each operation, write the answer in simplest form. The way I like to solve these problems is especially when you have no idea what you're doing, right? So here they're asking you perform the operation and write the answer in simplest form. So what I need to do is I think about how can I do the prime factorization of the numerator? When you're multiplying, like this case, you just multiply across, right? So that's going to be 5 times, well, the prime factorization of 5 is a prime number. It's only divisible by itself and 1, right? So the prime factorization of 5 is just 5 and 1, right? And then you can think about 1. Usually we don't put that because the prime number anyway, 5. So, and 5 times 1 is still the same number, right? So the prime factorization of 33, besides 33 and 1, is going to be 3 and 11. So I'm going to put that here, right? This point means multiplication. It's not 5.3.11 or whatever. What I'm doing right now here is I'm multiplying these numbers, right? Don't confuse this with something else. And then this is 11, because 11 is a prime number again. And 35, if you do the prime factorization, you get 7 and 5, right? Because 7 and 5 gives you 35. Can you break down 7 and 5? No, because 7 and 5 are prime numbers, are only divisible by itself and 1. So you bring that here. So this cancels out, right? And you get, you can cancel the 5 as well. So you can see, right, how I cancel the numerator and the denominator. So what's left? 3/7. So that's my answer. So if you do the prime factorization, right, then you can get the answer of this. Of course, some people are going to say, oh, that I can do this, right? This is a division, 33 by 11, that's 3. And this and that, that's 5, right? And I get whatever, I'm sorry, 7 is here. I get 3 7s, right? You can do that as well if you know what you're doing. But if you don't know what you're doing, I strongly suggest you to do the prime factorization. It's easier. Remember, when you're multiplying fractions, you just multiply across. That's the easier way, okay? And you always want to do the prime factorization, because if you multiply these two numbers, if you multiply these two numbers like 33 times 5, you're gonna get a big number. And if you multiply 11 times 35, you're going to get a big number, and it's going to make the problem more difficult. So you want to make the problem easier by doing a prime factorization and making the problems easier that way, okay? So here, they want you to do this, right? 6 divided by that. There's many ways to do it. I'm going to use the concept keep, chain, flip because you will use it later in this course. Keep, change, flip. So what this means, keep, I keep the 6, I change the division into multiplication, right? Like you have before, and then you flip. But since I have here a mixed number, I'm going to make it into an improper fraction or proper fraction. Usually it's a improper fraction, right? Because you get a number bigger than 1. So that's going to be 7 times, remember, we're multiplying these two together first. So that's 7. I can do that here. 2 times 7 plus 4. So that's going to be 14 plus 4, that's 18, right? So remember, the denominator stay fixed. So that's going to be 7. So that's going to be 18 over 7. But remember, I say keep, change, flip. So keep, change, flip means this guy that I just make it into an improper fraction is going to flip, right? Because they say keep, change, flip. So this guy is going to be 7 over 18. Therefore, you can say, well, 7 is a prime number, so that's not going to change. But the prime factorization of 6 is 2 times 3, right? So that's going to be 2 times 3 and 7 on the top, right? Remember, when you have multiplication, you multiply across, right? You multiply like this, right? And you might say, what happened in the denominator? There's no number under the 6. You can put a 1 here, right? Right? 6 over 1 is the same as 6, right? So if you multiply 1 times 18, it's 18. If you do the prime factorization of 18, we can do that here, okay? Let me do that here better. 18. The prime factorization is 9 times 2. And then you do the prime factorization of 9, that's 3 and 3, right? So you can say 18, you can write it as 2 times 3 times 3, yes? So this can cancel, and you get 7 over 3, right? So unfortunately, they don't have the answer here as an improper fraction. So that means that I need to make it back into a mixed number. But that's not a big deal. We talked about that before. 7 over 3 is the same as 3 stay fixed, right? And remember, we want to go into 7, right? So 2 times 3, that's 6. That's as close as we can get to 7, right? So that's going to be 2 times 3, and that 1 is going to get 7. So the answer should be 2 1/3, right? And that's option A. Okay? So make sure that you are tracking what I'm doing. Just remember this thing, key, chain, flip. It's going to help you a lot when you're solving these algebraic problems. This is not difficult at all. This is just calculation. If you still don't understand, I suggest you to rewatch it or go back a little bit and then watch it again. Okay. Okay, let's do the next question. The next question is asking you to add mixed numbers. So the easy way to do this is just add these two together. So this is 3, and now you need to add these fractions, right? This is these proper fractions together, right? So that's going to be 4 over 15 plus 7 over 20. And someone in class said that I need to find common denominator. Common denominator means these two numbers in the denominator, they must be the same. So I need to multiply by some number to make them the same, right? And someone in the class said that I need to multiply by 4. Okay, so if I multiply by 4 here, let me change the color so you see what I'm doing. So if I multiply by here by 4, I need to multiply the numerator by 4 as well. And if I multiply here by 3, I need to multiply here by 3. Remember, we're trying to find the common denominator, and the common denominator between 15 and 20 is 60. Okay, so if you compute that, remember, you're multiplying across like this, right? So that's going to be 16 over 60. And here we're going to get 21 over 60. Now that you have the same denominator, you can add the numerator. So that's going to be 37 over 60. So that number, you bring that here. So you're going to put 37 over 60, right? So let me put that in red because that's the final answer. Let me change this. So this is the answer. So let's see what is that here. You see, it's not that difficult. Okay? It's not that difficult. Let's continue. So here they're asking you to subtract. Now the 5 was adding. Now you need to subtract. Same thing. 14 minus 6. What is 14 minus 6? 8. And now you have the improper fractions, right? The proper fraction, I'm sorry. Now you need to find common denominator, right? So what is common denominator between 7 and 3? 21. So you need to multiply here by 3, and here you need to multiply by 7. Also notice that we're multiplying by the, if you notice these two fractions, the 7 is multiplying the 3, right? And the 3 is multiplying the 7. So that's another way to remember, oh, how can I find common denominator? Okay, I need to multiply 1 by 3 and the other one by 7, right? You can remember that way, easy, right? And you just need to multiply here by 3 and 3, right? And here by 7 and 7. So you multiply across, like I was saying before, like this. So that's 12 over 21, and here's 7 over 21. Subtract those numbers. Since you have the same denominator, 12 minus 7 is 5, and this is 5 over 21. So this is answer, right? 8, 5 over 21. That's it. Simple. Very easy. Okay. If you don't understand, go back to the video, right? Okay. So here, they're asking you, to which set of numbers does the number belong to? Okay. You know right away that 31 is a prime number. You should know that, because a prime number is only divisible by itself and 1. There's no such two numbers other than 31 and 1 that when you multiply give you 31. Now, if you forget all these concepts, I think I went over in class, but I was a little messy because I didn't have this chart. So if you think about what these numbers are, let me show you a chart, and then it will make sense to you. So here, really quick. So here is the chart that you have to remember when you're doing these regions tests or whatever. The natural numbers are the counting numbers, basically. So the numbers that you can count. Like you don't count 0, right? You count. Counting numbers means 1, 2, 3, 4, 5. When we're counting something, when we're counting like we have 1 apple, 2 apples, 3 apples, we don't say we have 0 apples, right? That doesn't make any sense. We're using counting numbers. So counting numbers are from 1 till infinity, right? And all these numbers are positive. So the way they express those numbers, they write as n. N stands for natural. Okay, so you can put that here. N is natural numbers if you want to put that. Okay, put this in. Okay, and then the next set is the whole numbers. The abbreviation is W, so that's whole numbers. So what are the whole numbers? Basically, the whole numbers are just natural numbers, but you need to include a 0, right? Okay, so whole numbers are the natural numbers and 0. So that means that this set right here, we call set like a bigger group, if you want to think that way. The set for whole numbers is bigger than the set for natural numbers. Why? Because in the whole numbers, we include 0. In the natural numbers, we don't have a 0. So that means that we have one more number, right? So this W is bigger than this natural number, right? If you think in terms of inequality, right? Okay, but that's the whole point. So the integers, what are the integers? They represent by C. So these are the integers. What are the integers? The negative numbers, the 0, and the positive numbers. Or you can think about the whole numbers and the negative numbers. Or you can think about the natural numbers, the whole numbers, and the negative numbers, right? So that C is a bigger set, right? So the C is like here, and within the C you have the whole numbers, right? You have the whole numbers, and you have the natural numbers inside, right? So the C is like the bigger set, right? We call it math, the bigger set, and W and N are subsets. Subsets, it means sets. Subsets means little groups of the bigger set. You can think about it like that, right? And that C And then after that, you have the rational numbers, right? The rational numbers are represented by Q. Put that here. So Q are the rational numbers. So what are the rational numbers? Well, by definition, is defined by an integer over an integer, right? So you can have an integer P or Q. These were P and Q, where, let me see, where P and Q are integers, right? We define integer by C. We talked about that before, right? So these PQ are two integers. So for example, the first number that we have in the rational numbers, we have -3. So -3 can be expressed as 3/1, right? Because that's -3. Is -3 an integer? Yes, that's right here. And is -1 an integer? Yes, that's right here. So that is a fraction, right? It's a quotient of two integers. Basically, that's what a rational number is, right? So 1 is an integer. This is also an integer. And negative is integer, right? The 0 is also an integer, right? So we know that from before. 2/3 is an integer because it's a quotient of two integers, right? 2 and 3 is two integers. 3 is also an integer. 2/5 is also an integer. And you might say, what about the last one? The 5 or 5.78, and what this thing represents? This thing that you see like a hat, meaning that at that A, it's going to keep repeating forever. So that means that this is going to be 5.8, whatever, right? So if you see on the exam that they write something like that, that you see that it's a repeating decimal, it can be also like this, okay? So if you see a repeating decimal, that's also a rational number. So you can write that decimal as a quotient, okay? Only when it repeats itself. I'm gonna repeat that one more time. Like you see 5.78 keeps repeating, like, I mean, that this 8 will keep repeating. In that case, you can say it's rational because you keep repeating the 8. So the 8 keeps repeating. But here, also here, right? 5.8888888. This card means that it keeps repeating forever, right? So instead of doing that, they just write a hat here, right? So here for this one is 5.7888888, like that, right? So that means that that keeps repeating. If you see a rational number like that, then that means, I mean, if you're seeing a repeating decimal, that means that that's rational. However, if you have these guys on the right side, it's called irrational numbers. These numbers basically are made of, for example, here if it's not perfect square, like for example, here you have this is not perfect square, right? We don't have a square root of 2. We don't have a square root of 3. We don't have a square root of 5. This number, actually, this is 1 plus root 5, right? But anyway, anyhow, here we have root 2, right? So if you put root 2 in your calculator, you're gonna get 1 point blah 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 blah. But that's not gonna be repeating. They're gonna be different decimals. For example, if you put in your calculator the square root of 2, you get 1.41421356. There's no such a thing as repeating like this case. You see that? So when you have situation like that, then you know that that's irrational number, right? It keeps repeating and the decimals are not the same. So for example, like pi is 3.1415, blah, 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 blah. But they don't repeat, like this case. You see here, you repeat, right? Or if I give you 5.8, this is rational. If you see the decimal that is non-repeated decimal, like for example, like pi or square root of 2 or square root of 3, those numbers, the decimals, they don't repeat themselves. So in that case, you have irrational numbers. I mean, imaginary irrational numbers, right? So here you have square root of 2. That's going to be a non-repeated. I mean, it's going to be like you're going to get like a 1.414213 but they're going to continue forever. But you will see no repetition, right, on the decimals. So that's how you know that that's irrational. Like pi, right? Pi, like I said before, or square root of 3. Right? So those are the irrationals. So that's the difference between the irrationals and the rationals, right? For the most part, the rational numbers are defined by P over Q, where P, this is rational, right? Where P and Q are integers, okay? And also if you see a repeating decimal, right? Here you have irrational numbers are just basically when they go forever and they don't repeat the decimals. They don't have a pattern, or they don't repeat themselves. So it's just basically like 1.15, 2, 3, 4, 7, 8, whatever, right? So there's no pattern there, right? So that means that that's irrational. So let's go back to the question now that I explained to you what that is, and let's answer this. To which set of numbers does the number square root of 31 belongs to? So we know that that's irrational because that's going to be square root, because this 31, we don't have a square root of 31, that's going to be irrational. So if you put that in your calculator, you get 5.567776436. You know that this is irrational already. Okay, but the irrational numbers are within a bigger set called the real numbers. So this is answer for this problem. Okay. Let's see. Yes, that's the answer for that problem. So irrational numbers, if you go back to the chart, right? If you know that they're irrational, they're within the real numbers. You see here the title, real numbers. So this is the bigger, this is the like the universe, right? And inside this universe, they have like a like let's say that the real, I'm sorry, let me rephrase that. Let's say that the real number is like the entire universe, and these are like small galaxies or little planets within that universe, right? So that you can think about the irrational number. You can think about it's like the Milky Way, and you can think about like you know, in this galaxy you might, in another galaxy you might have so this is the bigger set. That's what I'm trying to say. I don't want to confuse you with all these concepts from other topics, right? So real numbers means that's a bigger set, and the irrational numbers are within the real numbers, right? So that's why I choose this this option for the multiple choice, right? Okay, so that's it. Now the next is very easy. The next, you just need to say whether it's less or greater or equal, right? So here we know that absolute value. We did this in class the other day. What means absolute value? Absolute value means I need to add these numbers and verify what's going on here, right? So if I do that, for example, if I have 18 plus 20, I'm just gonna copy that, and then -5, -2. You know you have to perform the operation, in this case addition, right? So that's gonna be 38, and here it's gonna be -7, right? Because this is like two negatives, right? So that's gonna give you, that's gonna give you another negative, right? So if you do -5 and -2, that gives you -7. Remember, absolute value, whatever comes out from absolute value is always positive. So this is 38, and this is gonna be 7. Now you ask yourself this question: what makes sense to put here? Can I say this one? No, that doesn't make sense, right? Because 38 is bigger than 7. So can I say this one? Are they equal? No, that doesn't make any sense either. 38 and 7, they're not equal. So the only choice that makes sense is this one right here, right? So if we put that, does that make sense? Is 7 less than 38? Absolutely. So that's the answer. So this is the answer for this problem. That's it. Remember, whatever comes out from absolute value is always positive, right? Next question. This is very easy. We just need, and remember, I always tell everyone when they're doing these kind of problems, everything starts from your mind. If you think it's easy, it's going to be easy. If you think it's hard and you're defeating yourself before you attempt to do the problem, then after that you are already defeating yourself. Think always is easy, even though you have no clue what you're doing. Try to start with, with that good vibe, right? So here they say evaluate the expression for the given value of the variable. So we need to solve for this. So that's going to be 5 times a, right? So a is here. So we're going to use substitution. A is -6. Then 5. By the way, I'm using this expression, right? That's what I need to evaluate, right? And then 5 times b. B is this right here. So b is -5. So we need to compute this is -30. Minus 25, and whatever that is, right? So that's -55. So this is answer. That's it. You're done. Next. So here they're asking you to evaluate the function, right? So how you evaluate a function? They give you, remember, this is the input. this is the independent variable. Let me put that here. Let me change the color also so you don't get confused. This is the independent variable. Sometimes this is your domain, right? Because these are the x values that you can put in the function, right? Also, this is the domain if you want to think in terms of domain and range. So this thing right here, this is a function. So what this function represents, or what is this function do? Well, the only thing I need to do to solve the problem is I need to plug the -3, the independent variable or the domain or the value of within the function, right? So I need to put k of -3, meaning every time I see x, I'm gonna put -3 instead. So that's gonna be 2, -3 to the second power minus 5 minus 3 plus 3. If you perform this operation, this is gonna be, okay, -3 to the second power. -3 to the second power means this, -3 times -3. And if you think about that, -3 and -3, that's 9. So I should put a 9 here. And just keep this, always remember this. Every time you square a number, it either is negative or positive. If it's in parentheses, it's always going to be positive, right? Because you're squaring. Think about negative times negative, right? That's 2 times negative. That's going to be a positive. So every time this is not just 2, okay? It can be also like even, right? So if I have like 2, 4, 6, every time that's even that exponent, if you have a negative within, it's always going to be positive, okay? Just think about that. And then you have here 15, and then you have 3 here. So this is 18 plus 15 plus 3. So that's going to be 36, right? If you add these numbers together. That's it. Okay, so this is your output, right? This is your output from this function. So this was your this is also called your input, right? Input, and the output is what the value that you get once you plug that -3 within the function, right? So sometimes that output you can call the range depending on if it's a one-to-one function or not. Well, we don't know that exact situation here, but if you plug the -3 within the function, then you get the value of the output, right? In that case. So this is just computation. Okay. Next, algebra. This is not difficult for you. Okay, so we need to solve the for y. So how you do that? Very easy. You just use distributive property twice. So this is 4y minus 12 is less or equal than, again, distributive property. 4 times 2y is 8y, and 4 times 1 is 4. Now I need to put the variables with the variables and the numbers with the numbers. That's it, right? So this is -4y, -4y. Can I do multi-step? I'm not gonna do multi-step. I'm gonna do multi-step the next question. Okay. So this I can cancel. I get -12 is less or equal than 4y plus 4. I need to subtract 4 in both sides because I need to put the numbers with the numbers. This cancels out. I get -16 less or equal than 4y. I need to solve for y, so you need to divide by 4. Cancel, cancel. You get -4 as an answer, right? That's it. That's the answer for this problem. Okay. Treat it like it is an equation. Think like that. Okay, here this is a lot of calculator. Okay, like, I mean, because they allow you to use calculator, that's not too difficult for you to do the problem, right? Okay, so here they said that the following table represents a sample of sales prices in thousands of dollars and the number of new homes available at the price in 2017. So they give you this one, right? This chart, right? Here they say the sale price be in thousands of dollars, right? So this is 160, 180, 200, 220, 240, 260, 280. And remember, this is in thousands, right? So that means that you need to multiply. If they're asking you for the real value of the money, that means that you need to multiply by 1,000. You don't need to do that right now, but I'm just saying. So in reality, this will be this thing, right? You need to multiply that by 1,000. So that will be 160,000, right? That's the reason they say 1,000 here. If you need to understand the context of the question, what they're saying there, just in case they want to be mean or they're asking you something that you have no idea what they're talking about, right? Okay, so that's the input. or the x values or the independent variable, and this is the dependent variable, this f of p, right? So they say the number of new homes available. So you have 126, 103, 82, talking about this, right? Right? So you have x values and y values, right? Input and output, you can think about that. So here they say state the linear relationship, state the linear regression function. So they want you to write a function for this f of p, right? That estimates the number of new homes available at a specific sales price p. Round all values to the nearest hundredth, right? Okay, so we can put this data into our calculator to find the regression function, right? Or the linear regression function. So let's do that. That's not a big deal. Let's do that really fast. And let me show you how to do that. That's not a big deal. What is that? I think I showed you the other day how to do this, but just in case. Okay. Give me 1 second. So now I clear my data first. Clear my data. I think I did this the other day. So you need to input the data, right? So you put stats, put edit, right? So here you need to put the sales price P, right? So you put that 160, 180, 200, 220, all those values, right? And on the L2, you put 126, 103, basically the dependent variable, right? Or the output. So once you do that, you go to stats again. You go where it says calculation, and you press number 8, or if you want to scroll down this way, that's easier. Go to number 8, where it says linear regression, and then you press this one. Enter, enter. Once you see X list, L1, Y list, L2, you're fine. So just press enter, 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 and calculate, right? So you will see this, right? So those are the numbers that you need for your regression line, right? So you have y equals a plus bx. A is 249.8571. B is negative 0.79. 28. Let's round it to 29. And v r squared, that's what they're asking you here, the coefficient of determination, right? Or the, I'm sorry, correlation coefficient they're asking. So this is 0.9106. Once you're done with that, then we're basically done, right? And let me see this thing, 0. So negative 0.9543, just in case I need that. Well, I don't need that for that problem. They're asking for the correlation coefficient, I think. Yeah. Okay. So now once we're done with that, let me get out from here. And let's go back to the slides. Okay, let me get out from here. Okay. So now I have the whatever the calculator gave me, right? So I need to write the equation. So A is my y-intercept and B is my slope. So the slope should be negative 0.7929 x, that's my slope, plus B, or plus A in this case, and the y-intercept is 249.8571. But I need to be careful here because they said round all values to the nearest 100. So what it means nearest 100? Nearest 100 means this. This is 10th 100, right? So that means I need to, if the number next to the 100th position is greater than 5, then I will need to round it. But here I'm lucky. Well, not lucky, but I mean, it's easy to do, right? So this is negative 0.79x, and I need to round this to the 100th place. So here I have 7, so that's going to be 249.86. So this is the true value of the function. This is what they want. That's it. You're done. Okay, once you're done with that, notice that I bring this number, right? This also, I bring this one with me because in the next question, they ask you, what state the correlation coefficient? The correlation coefficient is r squared. Okay, this is the correlation coefficient. What that means? Correlation coefficient, it states basically how strong the relationship between the, well, in this case, between sales price and the number of new homes available, how strong that relationship is. And that varies from -1, like I stated here, from -1 to 1, meaning what? The stronger the correlation between the variables, or the closer the number, your R square, to -1 or 1, the stronger the correlation. Correlation, it means when, as one, let's say, right, as one increases, as one, for example, like in this case, X and Y, let's say, or in this case, the sales price and the number of new homes, right? Let's say as the sale price increases, the number of new homes available also increases. That will be a correlation, positive correlation, right? Sometimes you might have, as one decreases, the other one decreases, right? So the correlation means, for our problem, we have 0.91, right? I don't know, we got a little different this time. Anyway, let me double check in the calculator what we got, just in case. No, the correlation coefficient is 0.91. So let me go back to the slide. Wait, you are sharing. 1 second. Okay, good. So we're good. The correlation coefficient is 0.91. So the correlation, so as you can see, 0.91 is close to 1, right? 0.91 is very close to 1. That means that the correlation is very strong, right? So that means that this line represents a good prediction for this value. So for example, if we want to predict, let's say we want to, let me erase this for you so you can understand what I'm doing. Let me move this around a little bit for a little bit. So for example, if I want to predict 350 here, what is the sale price when this is, or 360, because this goes even, right? It was 160, 180, 200. So doesn't matter. I can predict 352, but let's say 360. So if I want to find out what this value is, right? I don't have that information. So I would use this regression line to predict what is the output for that situation, right? Now, when you're doing that, of course, it's not going to give you the exact value from, for example, we don't have that information, but whatever that number is going to make a good prediction of this value, right? It's going to make up a good prediction of this value. Okay, sorry about that. It's going to make a good prediction of this value. So if, for example, if I use the regression equation and I put 360 here, this is what I mean. So if I put 360 here in the function, I would say -0.79 times 360, right? When I see X, I put a 360 here plus 249.86. So that will tell me information that I don't have in this data. It's a prediction. It's not exact, right? It's not going to be the same number though, but it's going to like give me a good approximation, right? Because how do I know that? Because the correlation coefficient is telling me that the correlation is 0.91, so it's very strong. So whatever I can, basically, I can predict the future, right? So if I put 360 there, I do the math, right? So 360 times 0.79, and that's going to be negative something, right? Negative 284.4 plus 249.86. And whatever this thing is, that's going to give me the result. As you can see here, these values, it seems that they're decreasing, right? As time goes by, right? As the sale price increases, for some reason, these values seems to me that they're decreasing with the exception of these two, right? But other than that, it seems like decreasing. So if you do that, right, 360, that's going to give you a negative value, which in reality, number of new homes available, you get, like sometimes you have to interpret this information by the context of the data that they give you, right? We cannot have negative new homes available, right? So that means at some point, this will stop, right? This will not continue, right? Because once you hit 0, then that doesn't make any sense anymore, right? This is a little bit complicated, right? I don't want you to go that deep. I'm just explaining to you these things. The only thing they're asking you in this problem, forget about the 360, if you don't get it or if it's confusing to you for now. The only thing that they want you to do basically here is you use your calculator to input this data, you find the data, you find the equation, which is this, right? Round it to the nearest 100, don't forget that, right? So this is your equation, the one that is in the circle, okay? This is the correlation coefficient, is not belong to this part of the question. This is also not part of the question. The only thing you need to basically do for part A is just write the equation based on these numbers, right? That's it. So here they're asking you, state the correlation coefficient. You found it. It was 0.91 from the calculator, right? This is to the nearest 100, so we did that already. Explain what this means. This means that this is a strong correlation, right? It's a strong correlation between these variables, right? That's all they want you to explain, right? Explain what it means with the context of the problem. So it means that this correlation is close to 1, is positive strong. If it's close to 1, it's positive strong. If it's close to -1, when it's close to 1, there's a positive relationship, right? Right. So when you plug this data, these values, it's gonna, as one variable increases, the other one increases. That's what that means, a positive correlation. If there's a negative correlation, that means the slope will be this, right? This way. Well, here in the context of this problem, right? This data is negative correlated, right? So the slope is negative. So you know when the slope is negative, it should be like this, right? So the points, they should be like this. So this is kind of an inverse relationship, right? As the sale prices increases, the new homes available decreases, right? Because remember, this is the Y values and this is the X values. So as the X values increases, the Y values decreases. That's basically what this is telling you, right? So we can see by the data that the correlation is positive. Okay, so that's what it means, but don't think too much, right? So the only thing you need to do for this problem is just find the regression equation, or the regression equation line, or the line of best fit. In this case, this is the equation that represents that, and you need to find the correlation coefficient. And when we calculate a correlation coefficient, it turns out to be based on the data. The correlation coefficient was 0.91. Okay. Yeah. So it's a strong, right? It's a strong relationship between these two variables. Okay. Yeah. So what you can say at the end is that as one variable increases, the other one decreases based on the slope, right? The slope was negative, right? The slope was negative, and we can see from the data that pattern, right? We can see that as X increases, Y is kind of decreasing, right? For a moment it goes up, right? But for the most part it's going down, right? Was 126, then 103, then 82, then 75, then it went back again to 82, but then it goes down drastically, and then again it goes down, right? So you can see that negative relationship. So this one, as this one increases, this one decreases, right? There's an inverse relationship between those two variables. So you can say that as well. Okay. So next question. I'm sorry about taking a long time, but I want you to understand that. Solve the equations. So here we need to solve the equation. We just need to subtract -2y on both sides, and then combine like terms. So we can say -20 in both sides as well. So if you get y here, this cancels out, and you get -17, and this cancels out, right? So that's the answer, right? We just I did a multi-step this time, okay? If you didn't get it, what I did is this. If it's confusing to you, you can do the variables first. 2y, this cancels out. This is y plus 20 equals 3. Now you need to subtract -20 in both sides. So y equals -17, right? So that's the same thing, but this is faster, right? This is faster, and this takes longer, right? Or slower. Now the next question, they want you to distribute. So this is negative y plus 1. This is negative 9, negative 5y. So what you need to do is combine like terms. You can add 5y in both sides. I'm going to do multi-step this time. So, and then I'm going to subtract negative 1 in both sides. So this cancels out, you get negative 10. This cancels out and you get 4y. We need to solve for y. So this is 4 in both sides. So y is going to be negative 5 halves, right? That's it. You're done. Let's try this one. We did this in class. I'm gonna go a little faster this time because after that in YouTube they don't want me to. I have to do faster because then after they're gonna put a longer video, right? So I have to do a little faster this time. So this is gonna be 6x. Here is gonna be 4.8, right? And here is gonna be x because you have to do distributive property. That's all I'm doing, okay? I'm doing distributive property. So here is gonna be x because 0.2 times 5 is just 1. And here I'm gonna have 0.8, and this is 6. Combine like terms, I get 5x. Here I have negative 4. I combine these two together, by the way, okay, to get the 5x. And then I got the negative 4.8 plus 0.8, that's negative 4, and this is 6. Add 4 in both sides, and you compute this thing, right? So this is gonna be 5x equals 10, and then you divide by 5, and you get 2. Okay, that's it. You're done. This one we did in class, this, and it's on the video too, right? So you need to isolate the absolute value, right? You can have 3 situations. The first situation is the most common one, the one that we have. Remember when we have 2 solutions, right? Absolute value of c. We have 2 solutions here. Then if we have ax plus b equals to 0, you have 1 solution, right? And then when you have ax plus b equals negative c, you know that there's no solution here. That's the same thing from the video, right? So let's do this. So I need to isolate to keep it in this form, basically, right? So I need to add 7. So this is 3x plus 4. This is 12. I need to divide by 3. I need to divide by 3. So this is going to be 3x plus 4. It's going to be 4. Now I can set up one absolute value positive, one absolute value negative, right? Or the 4, one positive 4, one negative 4, right? So let me do that here. So you don't need this anymore. You know what it is already. So this is 3x plus 4 equals 4. 3x plus 4 equals negative 4. And solve for x, right? So negative 4 in both sides. You know that this is going to be 0 here. And divide by 3, you get 0 anyway. And then here we do negative 4 in both sides. 3x equals negative a. Divide by 3, you get negative a over 3. So these are your 2 solutions for this problem, right? That's it. And you can check if you want after that in the original absolute value equation. Next. This I did in class too, right? I did this in class. Write the equation in slope-intercept form. What that means? Slope-intercept form means y equals mx plus b. Y equals mx plus b. But here, remember, you have 2 lines, right? So write the equation in slope-intercept form of the line that is parallel to the graph of the equation that passes through that. So parallel lines, they have the same slope. So because we have 2 lines here, m1 equals m2. Just keep that in mind, right? What m1 represents the slope of this guy, and what m2 represents the slope of the line that we're looking for, right? So here we have 3. Remember, this is mx. M is the slope, right? M is the slope. This is the y-intercept, right? Whatever that is, right? So what I need to do is since they have the same slope, I can just say right away. So this is going to be 3x plus b. I just need to find the y-intercept. And like I was telling everyone in class last time, this 4 over 7, it's not part of the line that it's given. That's part of the information that they give me to solve the problem. So this 4 over 7 belongs to this guy. So this is going to be xy, right? So what I need to do is just plug the values to find the y-intercept, right? So if y represents 7, and x represents 4, right? Then I can solve for b. So this is 7 equals 12 plus b. Subtract negative 12 in both sides, you get the answer, right? So b equals negative 5. So what is the equation? Well, it's this one right here. The only thing I need to change is this b with negative 5, and I'm done. That's it. That's the answer. You can call this, like I call it in class, y2, right? Because this is y1. There's two lines that they're parallel to each other, right? So here, let me do that. The first line, the y1 is 6. The y-intercept is here. This is 6, and this is a positive slope, right? The next line, they said, is 3x minus 5. So the y-intercept is a negative 5 somewhere around here, and the parallel lines, they never meet, right? So they have the same slope, but they have different y-intercept. That's what you need to remember. I'm gonna repeat that one more time. When you have two lines that they have the same slope, the two lines, they have the same slope, but they have different y-intercept, right? That's the reason we were looking for the y-intercept, because they're different, right? Otherwise, we will put 3x plus 6, and they will overlap, but that's not the case, right? They have different y-intercepts, even though they have the slope the same. So, so when you have two lines, like in this case, y1 and y2, parallel lines, they never intersect. They kind of facing each other, right? Like in this case. Okay, next question. You can rewind this if you didn't get it, okay? Write the equation in slope-intercept form. So again, they're asking you the same thing, right? So y equals mx plus b. That is perpendicular. Perpendicular means the slope of line 1, it's the opposite reciprocal. Remember I said that? M1 is perpendicular to M2, meaning that, for example, in this case, the slope of M1, what is it? 2, right? Remember, opposite reciprocal. Meaning that if this is the slope of the first line, the slope of the second line is a reciprocal. What is the reciprocal of 2? Remember, I can write this as 2 over 1. So that's going to be 1/2. And the opposite means the sign change. The sign in the slope, in the first slope, is 2, right? It's positive 2. So here it has to be negative 2. Negative 1/2, I'm sorry, right? So that's the difference. So opposite reciprocal means you flip the fraction, right? If you have just a number like here, 2, you can write this as 2 over 1. So you can remember the slope is rise over run, right? You can write this as 2 over 1. And then what you need to do, you flip the fraction and you change the sign. If for example, if this one was negative 2, then this will be positive, right? Opposite reciprocal, that's what that means. So this is 2 over 1, and in this case it was positive, so that means in this case it's going to be negative. Now you have everything to write the equation. So you have y equals, or y2 equals, negative 1/2. Let me put it here clearly, negative 1/2 x. Now you need to find what's b, right? Like before. But use this information, this guy right here. Remember, this is x and this is y. So you're gonna replace those values, right? So y equals 3, negative 1/2, x is negative 5, plus b here. Solve that computation, right? I'm gonna bring that here now that you can see it. So let's compute this. So we need to solve for b. This is 3, negative and negative makes a positive. 1/2 times 5. Somebody said in the class, can I leave it as a fraction? Okay, leave it as a fraction. It's okay. But if you want to think in terms of fractions, you can think about this is 5 over 1. I already explained to you how to multiply the fractions, right? So basically you multiply them across. Negative 1 times negative 5, that gives you positive 5. And 2 times 1 is just 2, right? And this is plus b, right? And I need to subtract negative 5/2 in both sides, and then I'm done, right? So let's do that part here, and let's finish it. So if I subtract negative 5/2 in both sides, this cancels out, and I have on the right side, I have b equals 3, right, minus 5/2. Now this is what confuses you, right? You need to find common denominator if you're doing with fraction. If you don't want to do fraction, that's okay. You can say, okay, this is 2.5, and you know that this is going to be 0.5, right? right? This is 0.5, and you know 0.5 is the same as 1/2, right? Like think about like 0.5 means half an apple. You have a whole, that's an apple, you cut it in half, that's 0.5. So you can go back to decimal if you can do that way too. So that means y equals negative 1/2 x plus 1/2. You're done, absolutely done. You don't need to do anything else. You're done. That's the answer. Okay? That's how you do that. Okay, let's continue. And these are the last ones, I think, right? I don't know if I think I didn't do this in class. I don't know. Let me refresh my memory. Okay, let's see. He said 2 points each. Are the lines L1 and L2 passing through the given pairs of points parallel, perpendicular, or neither? Okay, so basically we need to see if the slopes are the same or if the slopes are different, right? So they say line 1, they give me 2 points, right? They say, are the lines L1 and L2 passing through the given pairs of points parallel, perpendicular, or whatever? So here I need to check if they are, if what's the slope basically, right? And by the slope, I can tell whether they parallel or perpendicular, right? So I need to find the slope. How you find the slope? The slope is the easier way to compute it, right? Y2 minus Y1, X2 minus X2. This is just the change in Y with the change in X. I would, when we're doing in class, I will explain to you what this means, okay? Because sometimes this silly formula, you can just understand it intuitively and you don't need to do this silly formula all the time, but that's fine. Okay, so Y2. So you remember, this is 0.1. So that means this is X1, Y1, and this is 0.2, X2, Y2. So use the formula, right? So Y2 is 1 minus 2 over X2 is 3 minus X1 is 1. So if you solve that, you get negative 1 over 2. So this is the slope. This is M1 equals negative 1/2. Now let's do M2. So M2 equals, again, X1, Y1, X2, Y2. This is 0.2, right? So Y2 equals 0 minus Y1 is negative 1. So this is the negative from the formula and another negative, right? And then X2 minus from the formula and X1 is 0. So if you do this, you get negative makes a positive. That's 1. And this is 2 minus 0 is 1/2. So are these the same? No, because if they're parallel, the slope must be the same. Are these numbers the same? No, because one is negative 1/2 and the other one is 1/2. So this is not parallel. Are they perpendicular? Perpendicular, if they're parallel, the slope must be the same. If they're perpendicular, the slope is the opposite reciprocal, as we said, right? So let's check. Let's see if this is true, right? Okay. Let's see. So it cannot be, right? Because this is not the opposite reciprocal. If you, so this case is neither, right? It's not parallel and it's not parallel and it's not perpendicular. It's neither, right? Next question. So here we have to do the same, right? So what is the slope for the first line? X1, Y1, X2, Y2 for the first line. So negative 7 minus 1, right? And then we have 5 minus 2. So this is going to be negative 7 plus 1. And this is going to be 3. So that's going to be negative 6 over 3. So that's going to be negative 2. So that's the slope. So M1 equals negative 2. Let's see what we get for M2. So M2 equals X1, Y1, X2, Y2. Let's check. So this is M2 equals Y2 minus Y1, X2 minus X1. So that's going to be 2 over negative 1. So that's going to be negative 2. So you can see clearly that in this case, the slopes are the same. Therefore, they're parallel. So M1 equals M2. Therefore, these 3 dots means therefore, and line 1 is, or you can say L1 parallel to L2. Okay, that's it. That was your entire thing. The only thing difficult in this problem, I think, was the regression equation. Other than that, I think everything is pretty straightforward. Okay, if you have any questions, please let me know. Have a nice day.